In the first part of this question, we have to define lyophobic and lyophilic salt with suitable example for each one. And we also need to explain why the coagulation of lyophilic salt is difficult as compared to lyophobic salt. Lyophilic colloids are colloidal systems where the dispersed phase has a strong affinity for the dispersion medium. This is leading to a stable and easily formed suspensions, and these are also known as solvent loving or solvent attractive. An example is gelatin in water. Gelatin molecules interact strongly with water and they will form a stable and homogeneous gel-like suspension. Whereas lyophobic colloids are the colloidal systems where the dispersed phase has little affinity for the dispersion medium. It makes the colloidal system less stable, and they are also known as solvent repellent or solvent hating colloids. A best example is metal salt such as gold or silver salts. The metal particles have little affinity for water or dispersion medium, makes them prone to aggregation unless stabilized by the additives. Now, the coagulation of lyophilic salt is difficult because these colloids have a strong affinity for the dispersion medium, which leads to a stable and well dispersed system. The particles in lyophilic colloids interact favorably with the medium, making it harder to aggregate or coagulate them. Coagulation typically requires a significant change in conditions such as the addition of large amount of a coagulating agent or a significant change in pH or ionic strength. Whereas lyophobic salts have less affinity for the dispersion medium and are less stable, the particles in lyophobic colloids are more prone to aggregation and coagulation because they do not interact strongly with the medium. Coagulation can occur more easily with the addition of the coagulating agent or changes in the medium such as adjusting the pH or increasing the ionic strength. Now come to the OR question. The first one is to define shape selective catalysis. Shape selective catalysis refers to a catalytic process where the catalyst structure allows it to preferentially catalyze the reactions based on the shape and size of the reactant molecules. This selectivity arises from the catalyst pore structure or active sites which can accommodate only specific molecule. This property is often utilized in the process like hydrocarbon cracking and is exemplified by the catalysts such as zeolite. The second one is Kraft temperature. The Kraft temperature is the temperature at which a polymer or material undergoes significant degradation or structural changes. For instance, in case of the polymers such as polystyrene or polyethylene, it is the temperature where the material starts to lose its mechanical properties and begins to degrade. This temperature is critical for processing and application purposes as it indicates the upper limit for safe use or processing of the material. The third term is peptization. This is the process of dispersing particles or aggregations into a stable colloidal suspension by the addition of the dispersing agent or peptizing agent. In this process, large agglomerates of the particles are broken down into smaller, more stable particles that remain suspended in the liquid. Peptization is commonly used in the preparation of colloidal solutions and is important in fields such as chemistry and material science for creating uniform and stable dispersions. So for defining each terms, you will get 1 mark, so the total mark will be 3.